Morning, class. Today we're going to be talking about distance time graphs and translating them into velocity time graphs. So we're going to take distance time and turn it into velocity time. So the first thing I want you to do is to open your notebooks, and let's get a title on our notebooks. And up at the top, let's put a title on this. We're going to title this, oops, no, we don't want that. We're going to title this distance time to velocity time. And before we actually get started on the how to do this, we want to make a little cheat sheet for ourselves. It's going to make it a little easier. So let's start our cheat sheet. First thing in our notebook. Okay, our little cheat sheet. And I want to show you some little tricks. If you have, let's say that you have a graph that looks something like this on our distance time, and let's say that it's a curve going up like that. Okay, that means acceleration. The object is accelerating to the right. On your velocity time graph, you're not going to draw a curve going up. You're going to draw a straight line going up. And what this shows you, a straight line, is going to show you that as the object is increasing its velocity, okay, the velocity line goes up like this. Or on a distance time, the line kind of curves when you accelerate. On a velocity time graph, the line is straight when you accelerate. Okay. And then another cheat is on a distance time graph. If you see a line that's kind of going up straight like this, this means constant velocity. This would mean constant velocity to the right. On a velocity time graph, what that line would look like, a constant velocity, would just be a straight line like this, probably in the positive region of our graph. Maybe if our graph looks something like that, it would be kind of in the positive, because this is a positive slope. Now, one more cheat I wanted to show you, and that is, what if the line is on the distance time graph is flat? What do we do then? This represents zero velocity. So on a velocity time graph, what we're going to do is we're going to draw a graph. We're going to put a zero line in there, like this. And then we're going to draw a straight line right along that zero line to represent zero velocity. Okay, so those are the cheats that we're going to use. Now let's see if we can actually do this. So let's call this example number 1 in your notebooks. On the left-hand side of your page, I want you to draw this distance time graph, okay? And it's going to look something like this. Now, what does that mean? What's going on here? We've seen this before. So the first part of this graph is in two parts. Here's the first part. This represents constant speed, a constant velocity moving to the right. And then we have the second part of the graph. This is a flat line here. This represents the object has stopped, or zero speed, zero velocity. Okay, so what then would we draw if we were trying to turn this into a velocity time graph? So in your notebooks, you have drawn the distance time graph. Okay. Now I want, on the right side of your paper, let's see if we can figure out what the velocity time graph is going to look like. Well, I'm going to take this first line right here. This represents constant velocity to the right. Constant velocity, what does that look like? Okay, so over here, I'm going on my velocity time graph, I'm going to put a 0 line in. That represents 0. And I need to draw a line that represents constant positive velocity, and there you go. So right here, because this is in the positive region of the graph, and it's a straight line, it represents constant positive velocity. Well, what about the second part of the distance time graph? What about this part right here? Okay, how do I represent that over on my velocity time graph? Well, it's going to look like this. So I'm just going to come in, I'm going to draw a line like that. It means the object has stopped and it has 0 velocity. And the last thing I'm going to do is I'm going to connect those two lines. Okay, so here's my distance time graph, and here is the same motion in velocity time. Okay, let's try another one. Let's call this example number 2. Copy this down into your notebooks. Here's my first graph. Okay, distance time. And it's going to look something like this. Alright. It's in basically two parts, right? I have the first part is this flat line right here. We should know what that means. And then the second part is this upward curve. We should know what that means also. Alright, well, what is that going to be on a velocity time graph? Let's check it out here. VT. Now the first part represents 0 velocity. So I need over here a 0 line. I'm going to put a 0 line in right there. And I'm going to put a straight line on that 0 line, and that represents that the object is motionless. It is stopped. It's over here on distance time. Okay, it is not changing its distance. It's motionless. So over here, same thing, it has 0 velocity. Now, what about this curve? That's acceleration. That means a constantly increasing velocity. So over here, I'm going to draw it like this. Okay? So if you notice that curve, this curve right here has become a straight line. Okay, so let's do another one. How about this one? We'll call this example number 3. Okay, we're going to make it a little more challenging. Okay, what do we have here now? We have this. Distance time. Okay, watch out for this. That is not in our cheat sheet. What is going on there? What's the velocity time going to be looking like? And I'll give you a hint. We're going to have a 0 line. Okay. Okay. So copy this distance time on the right side of your notebook. And what about this guy? What is he going to look like? Notice that he is showing us this would represent the object moving to the left or having negative velocity. Hint, hint. This would represent the object having being motionless or having 0 velocity. So what would this graph look like? 0 velocity. There's the first part. And then having a constant speed to the left would be a negative velocity. Looks something like this. There we go. Copy that down in your notebook. Okay, let's try another one. Call this one example number 4. And example number 4, we're going to get even a little more complicated. Okay, watch out for this one. I'm going to have this, then I'm going to have this, and then I'm going to have that. That's my distance time graph. What is it going to look like in velocity time? Yeah, well, I'll give you a hint. We'll probably have to put a 0 in there. Okay. Over here, I basically have 3 parts. First part, this downward sloping line here. Second part, this flat spot. Okay, third part, this curving upward acceleration. Okay, so here's a negative velocity, constant negative velocity. Here's 0 velocity. Here's increasing positive velocity. So over here on the velocity time graph, okay, should look something like this. Constant negative velocity, 0 velocity, increasing positive velocity. So this right here corresponds to this. This at the 0 line corresponds to this. And then this right here corresponds to this upward curve. I'm going to let you try one on your own now. So let's call this example number, let's call this example number 5. Okay, tell me what you think about this one. Distance time graph. Okay. First segment, second segment, third segment. Okay, I want you to perhaps pause this, give yourself a chance to think about it, and what should this look like over on this side of the graph. Okay, so take a minute and pause this. See if you can put your heads together with someone that's seated close to you and come up with an answer. Okay, are we back? So, what do we have here? We have 3 parts to the distance time graph. We have this part, we have this part, and we have this part right here. Here, 0 velocity, negative velocity, positive velocity. All right, let's see if we can draw that. First part, 0 velocity. Oops, I didn't get that on the line, sorry. 0 velocity, negative velocity, positive velocity. I can't remember what, I think let's call this maybe example number 6. I think that's what I'm at. All right, you ready for a challenge? Let's do this one. Distance time on the left side of your notebook. Okay, here we go. Okay, so this graph actually has 4 parts to it. Okay, 4 parts. Let's see if we can figure out the 4 parts. First we have this part, okay. Then we have this part. Then we have this part, and then this line. We haven't covered that one yet. What on earth is going on there? So let's pause the video and see if you can figure out over here what that velocity time graph should look like. Okay, pause it now and we'll come back together. Work with someone close by, put your heads together, see if you can figure that out. Okay, are you back? Here's what I got. First part, 0 velocity. Second part, accelerating. That's going to be like this. Third part, 0 velocity. Fourth part, negative acceleration going down. There you go. Okay, so the substitute's going to pass out some papers, and the papers are going to have some distance time graphs on them, and what I'd like you to do is to copy those into your notebook, and then I'd like you to draw what you think the velocity time graph should look like. Alright, then we can kind of double check your work after you finish those. Hey, I hope you have a great day.